what's the research problem?
Given a keyword query and a set of entities, we would like to return to the user some set of entities in order of their relevance. So, assuming the keyword query is of this form, we'd like to return the set of entities whose attributes match the best.
Do you have a concrete example?
Take this example. Laptop is our entity type, and we've got attributes stated afterwards, and this is an example table in order of...
So you consider an entity table as an input?
Yes, we assume that we're given an entity table and a query log. The entity table lists all of the entities that have been extracted from the web and all of their attributes and values, and we'll also keep track of where we got those entities.
How are you going to use the query log?
Well, we'll extract some information from the query log in the form of an attribute frequency table and a value frequency table.
So how do you plan to return the top K entities?
Well, our solution involves first determining which attributes in the query correspond to which columns in the entity table. Once we have that, then we'll calculate a relevance score for each entity and then return the list of K entities in order of descending relevance.
So for the first step, how can you match the columns with the attributes?
Well, we need to evaluate the similarity between each query attribute and the entity attribute in the table. And so each column will be assigned some average similarity ranking.
Okay, so what's the definition of the similarity between two values?
We would like to incorporate both lexical similarity and numerical similarity in our comparisons.
So are you going to evaluate every single entity because it's time consuming?
Yeah, well, we'll only evaluate randomly selected entities until we have both evaluated a sufficient number of entities and we're confident that we've identified the corresponding column.
Okay, so now we know to which attribute refers each column. How do we rank our entities now?
Well, for each entity, we need to calculate a relevance score, and this will take two phases. The first phase will calculate the rank for based on the number of attributes that match, the degree to which those match, and the distinct number of sources in which each entity appears. Then we'll refine those rankings using the query log, and then take the top K entities from the refined rankings.
Okay, so how do your first score function look like?
We'll use a modified Bayesian weighted ranking function. It's modified in that we take into account the number of distinct sources. And from there we get a subset K prime of our original entities.
Okay, so now on this subset, how do you use the query log?
We'll introduce another modified Bayesian weighted ranking scheme in which we will weight each of these similarities according to their appearance, according to their values in the attribute frequency table, which is F here, and the value frequency table, which is G here. That is assuming for each one that does not appear in the query.
Okay, so after you can return the entity list.
Yeah, and then we'll take the top K from that refined list.
Okay, so it looks like it's more a heuristic approach.
Yeah, we're using more of a heuristic approach, but in the future we'd like to combine this with a more formal probabilistic approach.